Welcome to Drexel University's Center for Electric Power Engineering presentation entitled Advancing Service Restoration via Smart Grid Technologies. Today we will be discussing the power distribution system application of service restoration, which can be improved in advance through technologies emerging from the smart grid.
Service restoration is the process of restoring power to an out-of-service portion of an electric power distribution network following isolation of a fault through the process of network reconfiguration. To illustrate this concept, let's look at a single-line diagram of a 22-bus multi-phase distribution network. Occasionally, system faults occur for a variety of reasons, including fallen tree branches or windstorms, among others. The fault is isolated from the network by opening system protection devices, resulting in a restorable out-of-service area. Network reconfiguration is then performed by operating normally closed sectionalizing switches and normally open tie switches to create a new radial configuration. Switch operations are typically limited by the spare capacity available in adjacent feeders. The smart grid is enabling a host of new and innovative solutions to the service restoration problem. Currently, the majority of network switches are operated manually, requiring a qualified work crew to travel and perform each switching operation. Remote actuation enabled through the smart grid will allow system operators to select and operate switches remotely from a centralized control center, quickly restoring the load. Furthermore, lacking centralized control, the distributed intelligence being embedded within network devices may soon allow for autonomous implementation of restoration sequences through real-time measurements and distributed solution algorithms. Finally, the smart grid is enabling customer loads themselves to serve as an additional resource to improve service restoration. With widespread installation of smart meters, pricing or control signals may be employed to provide incentives for in-service customers to automatically or voluntarily curtail their demand, thereby increasing available network capacity.
To further demonstrate these concepts, Drexel's Reconfigurable Distribution Automation and Control Hardware Laboratory, or RDAC, will be employed. This laboratory models multi-phase power distribution systems. Some main components of the distribution network include a substation modeled by a three-phase variable autotransformer and a power station box. Overhead and underground lines and switches will be modeled by a distribution feeder box and a transfer station. Resistive loads will be modeled by light bulb banks. All of the components of the lab are drawn into a system diagram as shown.
In this experiment, a bus fault occurs. Switches are opened to isolate the fault. The customers downstream of the fault are out of service. The loss of service is observed by the light bulbs turning off on the light bank. Service restoration must be performed to restore as much of the out-of-service load as possible. Through the DMS and advanced communication controls enabled by SmartGrid, the operator is able to remotely restore the out-of-service customers by closing a tie switch. Notice that the out-of-service area lights have come back on. Although service restoration may seem like a simple concept, the problem size is very large. Distribution systems consist of unbalanced loads and not all switches are automated. In addition, the system constraints must be taken into consideration when performing service restoration. If the system limits are exceeded, more failures will occur. Thanks for watching. For further information, please see the references below.